A certain radioactive isotope is a byproduct of some nuclear reactors. Due to an explosion, a nuclear reactor experiences a massive leak of this radioactive isotope. Fortunately, the isotope has a very short half-life of 6 days. Estimate the percentage of the original amount of the isotope released by the explosion that remains 5 days after the explosion. Okay, so we're going to focus for a moment on this piece of information right here. This radioactive isotope has a half-life of 6 days, which means that it will decay to half of what it started with after 6 days. So this is unrelated to this problem, just wanted to give you an idea how this works. Let's say we started with 100, I don't even have the units here, let's say 100 grams on day 1 or day 0 at the beginning. Then on day 6, you would have 50 grams. Then on day 12, you would have 25 grams. Then on day 18, you'd have 12.5 grams, and so on. So the rate at which this decays is it decays by half every 6 days. So with this piece of information, we're going to be able to find the decay rate. So we're assuming that we have an exponential model, and an exponential model looks like this. A equals A naught e to the kt. And let's make sure we understand what these pieces are in place for, what they stand for. A naught is our initial amount. K is our decay rate. Missed some letters there. T is time. And A will be the ending amount, how much we have of that radioactive isotope after time. Amount after your time period. So that piece of information about having a half-life of 6 days is enough information for us to figure out this value of K. And we need that value of K to be able to solve this problem. So let's think about what we know. We have a half-life of 6 days. So that means we know the value of T. We know the value of T is 6. And then it looks like there's nothing else. And I've told you guys that we're going to be able to figure out K. That's our unknown value. But it looks like we don't know our starting amount. We don't know our ending amount. However, this idea of a half-life, remember here we said we were having each time, having what we have. So that means that even though we don't know the value of the initial amount or ending amount, we do know the relationship between those two. So what we know is that A will be 1/2 of A naught. So even though we don't know actual numbers, we're still going to be able to solve for that value of K. So we're going to write the formula. A equals A naught e to the kt. We're going to start substituting in the values. For A, I'm substituting 1/2 A naught. I'm leaving A naught alone. E, K is my unknown that I'm solving for, and T is 6 for 6 days. we have a half-life of 6 days. I'm going to solve this exponential equation by first isolating the exponential. We isolate the exponential by dividing both sides by a0. This cancels out a0 on the right as well as the left. And we have 1/2 equals e to the 6k. Now I can solve this exponential equation. We have 3 methods that we typically use. Relating the bases, which is making the bases the same on both sides. We can't use that way in this example. Or we can take the log of both sides, or we can convert it to a log. I prefer to take the log of both sides. So we're going to do natural log on the left and natural log on the right. On the right-hand side, we're going to use the power rule for logarithms. And the power rule allows me to take that power and make it the coefficient on the log. So that gives me 6k natural log of e. Natural log of e is 1, so that's 6k times 1, which is just 6k. And now we can solve for k by dividing by 6 on both sides. We have k equals natural log of 1/2 over 6. So I have a value for k. I can type that in my calculator. However, I don't typically like to use the decimal form of this because rounding can be an issue with these types of problems. So I'm going to type in my calculator just to show you how it's done. Natural log of 1/2 over 6. And we'll write it down, but I'm going to use the exact value. This is negative 0.1155. So I'm going to use this value in my next calculation because I'm worried about rounding issues. I also want to point out to you guys that this value of k came out to be negative, and it comes out to be negative when your amount is getting smaller. In this example, you start off with 100 and you go to 50 and then 25 and then 12.5. That is decaying or getting smaller. When you have something that is growing, we call it a growth rate, and that value will be positive. Okay, so we're going to continue on with the second part of this question. So with the second part of this question, it says estimate a percentage of the original amount of the isotope released by the explosion that remains 5 days after the explosion. So we're going to use our formula again. A equals A0 e to the kt. And if you'll remember, we do know k now, and we are given 5 days for our time. And it says estimate the percentage of the original amount. So what's going to happen is we're going to substitute k and t in for these spots. We're going to get a number out of this part, and that will be our percentage of the original amount. This will be the percentage of A0, the initial or original amount. Okay, so what we're going to do in our formula, A equals A0 e to the kt, we're going to substitute in for k, we're going to substitute natural log of 1/2 over 6, and in for time, we'll substitute 5. So I'm just going to show you in the calculator. I'm going to type it a little bit different the way I wrote it. I'm going to type it with the 5 in front. I don't have to use quite as many parentheses if I do it that way. So this is what we'll type in the calculator. And I'm only typing the portion attached to the E. I don't have a value for A naught. I'm typing E, the 5 times natural log of 1/2, 0.5, divided by 6. And that is 0.56, let's say 1, 0.561. So let's convert that to a percentage. That's 56.1%. And I'll write this in this order. And we are going to end up with this amount, which is 56.1% of the original amount. I'm going to zoom out so you can see the whole question at once, all the work. Thank you for checking out my videos. Have a great day.